Hey guys, we're going to talk about dot structures and ionic bonds today. This is the third time I've tried this video, so I apologize if I go a little quickly. I'm having some technical difficulties. Alright, so our learning targets today, we're going to draw dot structures. I have another video that shows the dot structures both for single elements and representing ionic bonding. We're going to talk about what ions are and what type of elements become which type of ions and why. We're going to talk about how ionic bonds form and predict our formulas. Okay, so our dot structures use dots to represent valence electrons, and remember your valence electrons, if you look at your periodic table, group 1 has 1, they all have 1, group 2 has 2, 13 has 3, 14 4, and so forth. Okay, so those valence electrons are the electrons in the outermost energy level that are in charge of bonding. So if we look, we could also look at the electron configuration and figure out how many valence electrons we have by adding our final S and P together. So boron has 3 valence electrons. However, I think it would be kind of crazy to make you do electron configurations when you can just look at the periodic table and memorize that it goes 1, 2, and 3 through 8. Okay. So the symbol of your element represents the nucleus of your atom and all of the other non-valence electrons. The dots represent your valence electrons. And I don't like how they did this because they paired them up. They should all be unpaired, okay, until you start doubling up. So you would put 1 here, and 1 here. Okay, and that's how you would draw the boron. Here's the dot structures for the first 20 elements. Again, they pair these up, and they shouldn't, so it should go 1, 2, 3, there should be 1 down here, and 4. And they should be 1, 2, and 3. The dots should be 1 and 2. Okay. What we're looking for when atoms form ions or charged, basically become charged, they're going to lose or gain electrons so that they have the same configuration as a noble gas. Okay, here's our noble gas configurations. Remember, 8's our magic number because it's stable. Okay, that means that the outermost energy level is full, and that is the most stable way for an atom to be. So our other elements, our metals in our group 1 through 7, 1A through 7A for our representative elements, not including our transition metals, they're going to gain or lose enough to have the same number as a noble gas. Okay, so questions. How many valence electrons are present in an atom of bromine in the ground state, so in a normal state? And how many does bromine need to gain to have the same electron configuration as a noble gas? Okay, if we look at bromine on the periodic table, bromine is number 35. It's in group 7A or 17. So it has 7 valence electrons. Okay, and what I always ask myself is, it needs to have 8 or 0. Okay, so is it easier for an atom to gain 1 electron to get to 8, or is it easier to lose 7 to get to 0? Well, it's going to be easier to gain 1, right, because it's the smaller number. So you're going to gain 1 electron to have the same configuration as a noble gas. So the answer here is D. How many valence electrons are present in an atom of aluminum? Okay, if I look at aluminum on the periodic table, number 13, it's in group 3A, has 3 valence electrons. Okay, so we can eliminate C, D, and E. We know it's one of these. Okay. What charge will it form when it loses those electrons? Okay, So it says we're losing 3 electrons. Remember that electrons are negatively charged, so we're losing 3 negatives and it becomes positive. Okay, so the answer here is A. Another way you could know is that aluminum is a metal. Okay, metals become positive ions, nonmetals become negative ions. Okay, here's showing kind of the same thing, how an ion forms. So your sodium has 1 valence electron. It's going to lose it because it's easier than gaining 7, right? So it's easier to gain 7. Right now, our sodium, if we look at the periodic table, has 11 protons, and in a neutral atom it has 11 electrons. Okay, when we lose one of these electrons, it becomes a positive charge, right? Because we still have 11 protons, that's not changing, but we only have 10 electrons. Okay, so there's more positives, there's one more positive than negative here, so we become positive 1. Chlorine is number 17, has 17 protons, 17 electrons in an uncharged atom, but chlorine wants to gain 1 electron to get 8 valence electrons. Okay, so when that happens, we have 18 electrons here, 17 protons, we have 1 extra negative charge, which makes this a negative ion, -1. Okay, so those losing or gaining electrons is what makes it an ion. When that happens, when we have these oppositely charged particles like a +1 sodium and a -1 chlorine, opposites are going to attract to each other, and actually this sodium that loses an electron to the chlorine atom, which gains that electron. So the chlorine gains the electron that the sodium loses. That's why we draw the arrows. Okay, it's transferring over. So if we're drawing our dot structure, okay, we draw our 1 dot, it goes into where there's an unpaired, and we get sodium chloride, okay, which is an ionic compound. Ionic compounds become crystals, and all I really want you, I'm not going to say too much about this, but a crystal structure is very stable, and that's why ionic bonds have the properties that they have, is that those bonds don't want to break because of how stable that structure is. When atoms become ions, their size changes. The radii are going to change. So in metals, we're losing electrons. Okay, and whenever we lose something, it's going to make it smaller. Okay, so here's an uncharged atom. Here's the ion. It's getting smaller when it becomes an ion. For nonmetals, it becomes bigger because we're gaining an electron. Okay, metals become cations. I always remember cations because of plusicat. So plusicat are positive. Okay, positive are cations, and anions are negative. So which element forms an ion that is larger than its atom? Okay, well we just saw that gaining electrons makes it larger. So which of these gains electrons? Lithium loses, calcium loses, chromium loses, fluorine gains. Okay, so fluorine is the answer. Fluorine would gain. I'm going to skip this. You can watch the other video to show this. But basically this is just showing where these electrons go. Okay, so if we have 1 magnesium, you need 2 chlorines to get rid of these 2, I shouldn't say get rid of, to transfer those 2 electrons. We did this one on the other video as well. Aluminum has 3. Oxygen has 6. So you need to keep adding until you get rid of all of the electrons in your metals, and all of your nonmetals have 8. Alright, a chlorine ion has an electron configuration similar to that of what? Okay, so you're going to look at the periodic table. Chlorine is number 17. If we add an electron, because it's a -1 charge, we're adding an electron, it's going to have 18 electrons, which is the same as which noble gas? It would be B, argon. I'm going to skip this part because I don't think, I mean, you can look over it if you want to, but it's basically saying that the elements that are in each group have similar properties, okay, because they have the same valence electron, the same number of valence electrons. They react in a similar way. This is kind of saying the same thing. Alright, so if we have calcium phosphide is Ca3P2, the empirical formula of barium nitride is what? Well, calcium and barium are in the same group, and nitrogen and phosphorus are in the same group. So if we know that this would be the same. These little subscripts are going to be the same. So it would be Ba3N2. So that would be D. Some characteristics of ionic compounds is they form crystals, and because of that crystal structure, they have high melting points and boiling points. In fact, if you tried to melt salt, you wouldn't be able to do that. It has such a high melting point that you wouldn't be able to. They're hard and brittle. When they're dissolved in water, they conduct electricity because those ions break apart, and they're good insulators when they're not dissolved in water. Alright, again, if you guys have any questions, please let me know. I'm here, and if you need to meet, we can always do that too. So, I'll talk to you soon. I hope you have a great day.